Example 9, for the following function h of x is given here, evaluate h of negative 4 is what part A wants us to do. So what we need to do with the negative 4 is plug that in for our x. So go up to your piecewise function and think about where negative 4 would fit. So is negative 4 less than negative 3, or is it greater than or equal to negative 3? So negative 4 is less than negative 3. So we are going to plug negative 4 in for that x value. So we need to say that h of negative 4 would equal 2 to the negative 4th power. And then clean that up. So the negative 4th power we could fix by putting 2 on the bottom, and then it would be a positive 4th power, or in the denominator. And then let's just simplify that a little bit more and say that that would equal 1 over 16. And that is it for part A. So for part B, it says evaluate 3 times h of 0 plus 2 times h of negative 3 minus h of negative 6. So it just takes it a notch up from what part A was asking you for, but basically the same idea. So these are going to be our x values that are in parentheses, and we're going to still go up here and see where we would put it. So 0, if that was our x value, we think about, is it less than negative 3, or is it greater than or equal to negative 3? So 0 would fit in that second part of our piecewise function. But then if you plug in 0 for this x right here, 3 divided by 0 is undefined. So even though they're asking us to do that, we can't, because we can't divide by 0. So that part would just not exist. And then we need to continue on for this next part. So let's think about negative 3 now. Negative 3, if that was our x, would fit into the second piece of our function because it says it's equal to negative 3. So then we plug it in for this x over here. And we would say that that is equal to 3 divided by negative 3. And we'll clean it up in a minute. Then we're going to subtract h of negative 6. So we got to plug in x equals negative 6. So thinking of negative 6. Negative 6 is less than negative 3. So we need to plug it in for this x. So minus, and I'm going to put this in parentheses, 2 to the negative 6th power. And then we're just going to clean all that up. So in the first piece of our problem here, we have 2 times 3 over negative 3. So that's 2 times negative 1. Minus, and then we have 2 to the negative 6th power. So let's make that a positive 6th power by moving the 2 to the denominator. And then we'll continue cleaning it up. So 2 times negative 1 would give us negative 2. And then minus 1 over 2 to the 6th, which equals 64. Then you can certainly type that into your calculator, or we can just give the negative 2 a common denominator. So if we want to make it into 64, so they match, we got to multiply by 64 because right now there's a 1 in the denominator. So then we end up with negative 128 over 64 minus 1 over 64, which gives us a grand total of negative 129 over 64. So that is our final answer for part B. Now part C is asking, what is the domain of h of x? Explain your answer. So the domain of h of x, if we look back up here at our function, looks like it's all real numbers because it includes all the values less than negative 3 and all the values greater than or equal to negative 3. The only problem is it has x in a denominator right there in that second piece of our function. So what we could say is we can write it a couple different ways. So let's write it as interval notation and say negative infinity to infinity, but x cannot equal 0. We could say that x is all real numbers. So we could say that x is greater than, let's write it just all real numbers. So all real numbers, and x is still not equal to 0. So those are two ways to write it, and those would probably be the most appropriate. Interval notation, I would say, would be the one you're looking for most frequently. And explain your answer. So let's explain any denominator cannot equal 0. We cannot divide by 0. So denominator, let's put the denominator cannot equal 0. So again, in that second part of our function, that's where that occurred. All right, so that's it for example 9.